have a TT-F1-less SL-F1. Let's crack on. Hello and welcome to another MrBetaByte video, and this one's a little bit different insofar as we have a repair in, and it's a Sony SL-F1 UB, and this has been sent in by Eric. Hi Eric, hope you're recovering well and fantastic you're getting back using the kit again as well. So no idea what's wrong with it, but I do have a problem. I don't actually have a TT-F1 at the moment that's working anyway. So my thought, and I've been wanting to do this for a very long time, and I've never been able to justify the time to do this. But I had ages ago a TT-F1 that was quite seriously damaged, and it was just a total basket case. But you know, I saved some of the parts and whatever. I also saved the lead, and this thing is like gold dust really, because it breaks out so much. Bit of a change of plan insofar as Eric has now sent me his TT-F1. This has no clock, so we'll have a look at that probably in a separate video, to be fair, because I might have something quite neat that can replace the units that fails, the DC-DC-AC unit under here. So yeah, but it should be enough to at least get this up and running, to test it, see what's going on. And yeah, so let's power it on. It appears to be completely dead. That is not a good start. Is it completely dead? Am I missing the point? Yeah. So obviously there's no clock. Yeah, so the power supply's not starting up on this. So maybe we need to have a look at this first. Okay, let's do that. I will just check the plug and just see what's going on with that. Yeah, it's all connected. It's pulled out of the cable grip, so that's not ideal. And of course it's an old plug, so it hasn't got the shrouded pin, so I need to sort that. I'll have to change that, but it's connecting. It's connected, so that's something. So I suppose we ought to have a look at the TT-F1 then. Now it's me saying we'll look at it in another video, but no, it's going to have to be this one. Let's crack on. Well, I don't know whether you can quite see that, but that tells a story. That fuse is completely atomized, so I would say we have a shorted power supply. Probably both those transistors, main transistors, are blown, and probably it's leaky capacitors that have caused it. So let's take the can off and have a look inside. Mains connector to come out. So obviously connector goes from there to the switch at the front and then back to the power supply. Then we've got connector here, tuning board connector there on the tuning board. Which really does not want to come off. And connect to the front clock and bits and pieces board. Let's move that out of the way. Oh, let's just get these two screws out as well that I dropped. A bit of plastic floating about. Okay. I'll just rest that up there for now. So the fun bit is getting this out, and this is a point where I usually end up covered in silicone grease. There we go. So a little spot of glue which made it seem a lot more difficult than it actually was. Then these screws have to come out. So you can see the silicone grease there. I think I can pull this out now. I'm just looking at those. I'm just a bit dubious because of those screws, but I'm pretty sure I don't have to. I've done so many of these, I still can't remember. There we go. Okay, and then battle's not over yet. This is glued on. You can see some of the glue there, and this will be. There'll be a lot of glue because they use it to isolate between the hot and cold sides of the power supply, so the mains and the secondary, if you like. So I find, rather than trying to slide it off, just unclipping it and slowly working it off, or scraping it, depends. Sometimes they're really well glued, sometimes they're not. Yeah, I'm struggling to get that side up, so I think this is going to be one that's well glued. Yeah, it is going. Just get a screwdriver down where it's splitting, and it'll just split off the plastic. It can be a bit of a pain, this stuff, because it's usually where you want to solder as well. Yeah, to be fair, quite a lot of that is already broken. There we go. Just minding my fingers because I knew that was just gonna go. There we go. So that's off. Shouldn't really be holding it by that board, but it's okay. So those are the two suspect caps, and there's also a cap in there that I do tend to change these days as well because they do dry out and it stops the power supply startup circuit from working. So I'll do that. Probably these will be short. In circuit they'll appear short anyway because they go across that transformer of very low resistance. So they'll have to be desoldered probably to really get an idea of what's going on, unless they're completely short right the way through. But I would suspect those two caps are completely fried. So yeah, so you can get the plastic cover off that bit there. My lights has gone off, so it's not ideal. That is actually gooey, so that's from the side here, sticky. So they do that. The other cap is that one, which is, somebody just commented actually they got theirs going because of that cap. So there's a 22 microfarad 50 volt in theirs. 22 microfarad 50 volt, yeah, so that's what that is in there. So that one there. Okay, so I suppose we ought to desolder stuff and see what's going on. Let's crack on. Yeah, so it's see, dry joint there actually, or a bit of a bad joint anyway. So I don't know, it's quite dry, but there's sort of something strange over the PCB. I don't know quite what that's all about. Let's see if we can just wipe it off. I think it's actually some of the whatever they put on the plastic, on the sorry, the shrouding on the transformers. That sort of rubberized material that they put on. This has got hot. Which probably hasn't helped the capacitors in there for life. Having said that, I mean, what was it, 40 years old, so yeah. Let's whip those caps out and see what they're like. So yeah, it's game over for these. The leg actually broke off on that one, or yeah, it wasn't. It was rotted well and truly. So yeah, that'll mean both those transistors will be blown as well. I can guarantee it. So I'll whip those out as well, and I need to clean up where the wire is broken off there, the lead. Fun begins with the glue. You can see it's everywhere. It's not too difficult to get off, but it is difficult to get it really, really spotless sometimes anyway. This seems to be coming off quite nicely. So let's give them a test. I'm just going to test this on resistance, to be honest, because I'm pretty confident they're going to be short. Yeah. Completely short. So, 2 more. So I'll get this fitted. And obviously those 2 caps as well, because I think they're a bit second-hand now. And I'll change that 22 microfarad capacitor on the starter circuit as well, and we should be good to go. Let's crack on. Just checking through, I've changed these 2 capacitors. They're actually 400 volt, 4.7 microfarad. So just sort of up them a little bit for what it's worth. Don't think it makes a huge amount of difference. I've taken out that 22 microfarad 50 volt capacitor. 2.2 microfarad 50 volt capacitor. And I don't have one, so I'm going to have to get one, which is not a problem because I'm about to go on a holiday for a week, so it can arrive while I'm away, and we can finish it off on my return. Also transferred the ferrites over to the emitter of each of the 2SC 2938s. I'll just triple check these, and they're testing fine. They're new old stock, I believe. These ones rather than liberated, so they should be fine. So yeah, I'll get the transistors put back in and await the capacitor. This does look as if it's been a little bit stressed. I actually got it out without taking the board out as well. That transistor was already bent like that. So obviously when they put the plastic on, it sort of bent it. But yeah, so I'll get those transistors soldered in, and then on my return solder in that cap, and we should be good to go. Well, it ended up being a bit pointless taking that cap out without taking this out, because getting the new one in, it's almost impossible. So I have taken it out. It's easy enough to do. But it just goes at a slightly odd angle as well, and it's a tight space, and I think it's a slightly bigger capacitor as well. No, I don't think so. No, exactly the same size. Yeah, I suddenly remembered I did order some, so yeah, 2.2 50 volts. So I'd ordered some in my last Farnell order, and they just weren't in the usual place. I hadn't filed them yet because it's been so busy. So yeah, I'll get that put back in. Transistors are in now as well. Not bad soldering. I don't use printed circuit board cleaner, a flux cleaner, on these boards because it makes the varnish sticky, reacts with the varnish. So I just very carefully just remove the flux just scrape it off basically, and that's the way Sony tend to just leave it on, to be honest. But yeah, so I'll get this back in and get it put back together, and then we'll look at that fuse. I can't remember what value it is. Does it say on the board? 1.6. Slow blow 1.6. So yeah, I'll change that as well, and should be able to give it a try. Let's crack on. So just before we try it, I have changed the plug, and yeah, nice job done. So get this back together, and we'll give it a try. I've plugged in the F1 as well, the SL-F1. So because from what I understand, there's no display on this, so we won't really know until we turn it on here if it is actually alive. But anyway, let's crack on. So I think we're about ready to give this a go, and yeah, I don't expect the display to light up, but hey ho, it is what it is. Let's plug it in and see what happens. I've actually got nothing at all, which is a bit concerning. Yeah, no, nothing. Okay, and we've got power on the front. That's on. Doesn't look like the fuse is blown. Ah, okay. So it is still dead. It's quite unusual for these to sort of play up like that. Usually when you do those two transistors, two caps, and the startup cap as well, that is enough. And obviously the fuse. The fuse is still intact by the looks of it. I know I've already said that before, but closer look. So let's go live. Okay, and yeah, I'll take this back out again. Bit of a faff. Wait. Overconfidence and all that. So, next thing I want to check is that the switch is okay. So, live. Neutral. So that's good. And I'm just checking that the switch actually is working as it should. Heatsink compound on me. I did put a little bit too much on, I have to admit. Okay, so let's just double check. Everything's plugged in. Like I say, they just tend to just work. Yeah, nothing at all. Let's just turn it off. So let's turn that off. Again, just checking the switch. Let's see if we have any voltages at all. Probably could do with looking at the service manual, but well, let's just go for it. So we've got tuning there. I would expect at least a 12 volt rail there. I just want to see if there's any voltage at this stage. I don't really care what they are. I just care that the power supply is working. So there's two browns there. Oh, I need a better grounding point. One that's reliable. To be fair, that's probably not ideal. Yeah, that should be good. Okay, so 2 browns, an orange and a red. Well, red is probably going to be 12 volts. Oh, bit of crack there. So it's obviously doing something, because there's a crack from the on-off button, the actual mains power button. So there's obviously something going on there. Okay. It's actually not that great if the switch is dodgy. Let's try. It's actually worth trying to see if we've got 240-ish volts on the AC. Yeah, so we have 242 volts. So that's working. Is it failing? It's obviously drawing current because I've got a crack from the mains switch. Yeah, I think what I'll do, I'll get the manual and I'll just see what voltages are expected, and we'll measure them. I've had a look at the schematic, and I should have 12 volts on the orange wire on the back connector there. So the 2 browns are ground, then orange is always 12, and the red is switched to 12. So that could be why I'm hoping why I haven't got any voltage, or wasn't picking up any voltage. So let's power it on and see what we get. Pin 12 is no connection. So looking at this, pin 12 is that end. There's no connection. No, sorry. Yeah, that end. So let's pull that out of there. T6. It reckons it's black. Oh, it is. Oh, I'm looking at a complete wrong connector. So T6 is that black connector. I should have. Brown is. Oh, I can actually hear the power supply is trying to run. Nothing there. Nothing there. Nothing. Nah, there's nothing. Nothing there at all. But I can hear that power supply. No, we can quite make it out. So something is not good in there, and I can smell that something is not good in there. So let's get it apart quick and see what it is. Oh, it smells horrible. How to describe it? It smells like ozone. So all apart again, and the startup circuit seems to be where the smell is, and the 2 transistors are quite hot. They are running hot, so it sounds like, literally sounds like the startup circuit is sort of locked. So it's trying to start the power supply, and it's not managing to do it. Now it could be a fault on this, or it could be a fault elsewhere that's stopping the full startup, or sort of kick-starting the running of the SMPSU, the switch mode power supply. So yeah, is it this or is it the power supply at large? Has something else been damaged? It could be because of an excessive load, possibly. It sort of depends how the power supply is designed. I suspect that an excessive load would not cause that problem. So the power supply would start up, but it would shut down the rails. I don't know. I'd have to have a look. It's not dissimilar to a C9, to be fair, in design, but I could be getting that completely wrong. But what else is damaged? That's the thing. I'm gonna go for it's a startup issue with the power supply, and assume that it's probably going to be this panel. This is the startup panel for the switch mode power supply. So this basically kicks the oscillation going to get the switch mode power supply running. So I'll whip it out, I'll do some checks, cold checks, and then I think what we'll do is we'll bung it on a piece of card, plug it back in and run it and just see what's going on. It's going to be fun. It's actually going to be quite a bit of fun. Let's crack on. Did lots of testing. I did wonder if I had a shorted rail on the secondary side, so I did just check them all through, and everything checks fine. Then I spotted this capacitor on the primary side, and I say spotted it because it was completely covered in this glue and glued, sort of bent over towards this transformer here, and yeah, it's 33 microfarad, 16 volt. So I'll just test it. Oh, it reckons there's a diode now. Really? Yeah, it was saying, the first time I tested it, it was saying it was about half of its value with the pretty high, yeah, oh gosh, ESR, it's changed again. 9.164 nanofarad. It was saying 60 microfarad, it's actually 33 microfarad. ESR's going up as well. So, yeah, that was pretty well had it. And it explains the smell as well, because the smell was coming from around this area, and I think it smells almost like ozone. It's really weird smells. It's not like the normal sort of maybe more fishy smell you get with some capacitors. But yeah, it was not happy. So I'm going to take the plunge, put this back together, put it back in the unit. I probably won't screw it in to the unit, but I'll put it back in its case. And I remember to put the plastic cover on the starter circuit as well. I did just check that as well. It's absolutely fine. Not surprised there at all, because yeah, it was fine. Because it was oscillating. You could hear it oscillating. So yeah, so I'll do all of that, and we'll give it another try. Let's crack on. All back together. So, moment of truth. Let's plug it in. Still nothing. I'm just trying it with the remote. Power supply's back out. I've set my meter to peak hold. I'm just going to flick the power for a second and just see if I think it's a 6 volt rail that I'm measuring. It's a rail basically that's there unswitched. So yeah, let's give that a go. Okay, that's not great. Oh, that's so frustrating. I really thought we'd sorted that power supply when I found that that bad cap, and yeah, I thought that was going to be enough, but obviously there is more going on with it, unfortunately. So just going to check the 6 volt rail. This is the unswitched 6 volts. Went up ever so slightly. Okay. Yeah, this is not happy, is it? Right, I suppose we better get a part again and take a look. Let's crack on. So we'll sort of set up to do some tests and just check the power supply, basically, sort of out of its cage, and just try and find out what's going on. It's all a bit weird because they're generally pretty reliable. Once you've changed those caps and the two transistors, they tend to be good. I mean, the start cap as well, that's a common one. And obviously this 33 microfarad cap, I think I have mentioned that before actually. It was so covered in glue that I just missed it. Covered in silicon heatsink compound again. Joys. So yeah, I have the schematic as well. It's obviously trying to work, but it's just something is loading it down or stopping it from working. You've got the control IC here, so this is basically controlling the 12 volt supply. So possibly we have an issue there. Don't know. We will find out in the fullness of time, no doubt. But yeah, let's crack on. Done some more checks. I just can't find anything wrong with this. I know it's oscillating as well, and those oscillations are good. Anyway, the startup circuit is maybe not kicking it, but I can hear it oscillating. So what I've done is I've disconnected everything, and I am going to turn it on and just see what happens. I might just want to isolate that a little bit more just in case. I'm sure it'll be fine. It's floating above the can anyway, but just for the sake of completeness. So I'm going to do remote power on. I'm just going to literally just flick the switch quickly. I haven't got a plug socket handy with a switch that I can get to easily. So yeah, I've got to sort of leave the room to just flick the power, but we'll see what happens. Yeah, absolutely nothing. So that voltage there that you're seeing, that's for me doing checks, and it's actually charged up the output trans capacitors. So that's just sitting there with the voltage that the meter put on it. Right, so this power supply is still dead, which is not good. It was oscillating, and now it's not. I assume we've got a bleed resistor, but I'm going to be careful just in case there is still voltage there. And trying to get covered in heatsink compound. Let's just see what voltage we have. So there's the output of the bridge rectifier. Yeah, 14 volts. So you know something's getting through there, and that's draining down quite nicely. I could do with measuring drive, which I should be able to do with a scope. Being a battery operated device, it is isolated. I think, where are we? Drive. It's on the other side of the transformer anyway, so it is isolated, but still, it's no bad thing, is it? So I'm going to need tip. I have actually got a new oscilloscope, which is a bit better designed for analog stuff, but I've got a few things I need to check on it first, and yeah, so I'll change the probe tip. I've lost the other one, of course. It'll be somewhere. And I need to find test point. Can't see that. Test point. Test point 653 drive. So that's going to be somewhere really inaccessible, I can tell. It's 22 volts. How high can I go? Uh, 50 volts. It's let me just check what it is. It's 22 volts, 33.5 microseconds. It's 50 microseconds per division. So we should see something on that. Okay. Let's see if it's going to oscillate. Do a quick switch on again. I've dug out a Sony C9 power supply, SL-C9, and this shares a lot of the same design characteristics as the TT-F1, and shares similar components. The switching transistors are different, transformers are different, pretty much everything's different except for the control chip, which is exactly the same. So I've taken the control panel out of, or C panel out of the C9 power supply, and what I'll do is I'll take the chip out of the C panel on the TT-F1 panel, swap the chip and see if that sorts the problem. Now the reason I'm doing that is that that chip controls the oscillation for the drive, and it also controls the voltage out on the secondary side. So the waveform that I was getting on the oscilloscope, that was actually it was actually wrong. It was much wider than it should be, which is showing like an overload or an error state. So I think the chip's bad because I can't find anything else that's sort of like a load, like a short on the secondary side. So it could well be wrong, and I have been many times before. But I'm going to change the chip. This power supply is a good power supply, and I will replace the chip on this and recap this, and I'll keep it as a spare. But yeah, let's crack on. Chip's out, so yeah, quite a tidy job. And yeah, let's put the other one in and see if it does make a difference. Let's crack on. Chip's in, and yeah, nice tidy solder job, or relatively anyway. It's a bit fluxy, but of course you can't use isopropyl or the normal sort of flux remover because it makes the varnish go sticky. So yeah, we'll clean that up, but yeah, I'm just eager to try it, to be honest. Let's crack on. So now we've changed the chip, I suppose we ought to give it a try. I've got the F1 plugged in, it's sort of outside there, but it is plugged in. So let's see what happens. Oh, that's brilliant. Okay. So we had a bad chip. So I do have another. I actually have another in stock. So that's good. I thought the display was bad on this, but it's not. Which probably means the caps are on the way out in that can. So yeah, that's working. Oh, that's fantastic. So that waveform, you could just see the duty cycle was just really poor. So yeah, it was just doing weird things. I think it was actually effectively thinking there was an overload. It was like in overload mode all the time. So yeah, it was almost like there was a short in the output. So that's really good. Excellent. Perfect. Right, so I've run out of time. Unfortunately, again, it keeps happening. We'll continue with this. We'll sort out we'll take the DC AC converter apart. I'm going to put this all back together. In the meantime, I won't bother showing that. You know how they come apart and go together now. And then we'll have a look at the F1 and see what's going on there. And I have a really good suspicion I know what's going on with that. So definitely worth watching and keeping an eye out for. So a like and subscribe would be fantastic. And obviously notifications for the upcoming video, part 2. And hype the video as well. It really does help. I really want to sort of do a lot more with video repairs and getting kit up and running, and reviews as well. And I really need the support to be able to do that, and also improve the quality of the videos as well, because they are a bit makeshift, aren't they? It's half the charm, but also it'd be nice to make them a bit slicker. So yeah, with that, thank you very much for watching. A like and subscribe, as I say, would be fantastic, and hopefully I shall see you in another video. Bye for now.